Hello again. So this week, I won't be showing you me solving everything here, but I'm just going to sort of go line by line through my APL solutions to the email address sorting problem. Haven't had loads of time, so I haven't tried the n-queens problem, but I will point you to the dfunds website, dfunds.dialog.com, and you can see what I can assume is John Scholes' work on the n-queens problem. And as is the case often with APL, so it's just a bunch of functions applied one after the other. Right. I suspect if it doesn't already, it will be very straightforward to take a similar approach for 3 dimensions. Oh, actually, you can see here. It's displaying these 2D grids. But if everything's done using numeric representation or indices, then yeah, moving up to 3 dimensions should be doable. And maybe I'll come back and have a go at some point. Right, anyway. So, sorting text is super straightforward in APL. The only annoying thing in terms of this problem, I didn't get as far as putting it into an actual command line utility with an option, but I have made a function with an optional argument. And then secondly, the annoying thing, the main annoying thing for solving this problem, is sorting firstly by these domains and then by the names, except the domains you can normalize because capital, 1 in all caps is the same as 1 in lowercase, but the names, or the mailboxes rather, you can't normalize because name with a capital N is distinct from name all lowercase. And then when you want to bring everything back out again, you want to keep the original casing. And if you do case folding, case normalization, I don't know of an easy way to undo that to get back to the original one. Right? You could upcase everything, but so that was the main problem. And you'll see I've got 2. Hold on. So this is my week 62 namespace, and in here I have 2 versions of the function, and addresses is just a simple text vector with embedded new line characters, and you'll see why I've got 2, right? So initially, the thought is basically split these up into domains and mailboxes. Mailboxes on the left of that, domains on the right, and then sort of you have to go through. I don't know. I didn't really think that well through it, but I did manage to fudge my way through it by doing multiple sortings, right? So first, I would, let's have a look and go through it. So alpha is my optional argument as to whether or not to return unique addresses. Then I'm just doing some formatting for ease of processing. So instead of a single character vector with new lines, I've now got a character matrix. Then for each row, so that's rank 1 here. Ooh, I don't need to split add mat, it's already split. Okay, so I can change that. So rank 1 means along each row, split text by delimiter, the delimiter being the @ symbol, and so that gives us this type of nested matrix. Then split transpose puts all my mailboxes in one vector on the left, in position 1, and all of my domains in another character vector. And I just wanted to pick the domains and then use quad C to case fold them down. So there's my normalized domains. Then I use that as the keys into the key operator to group all of my domains, or sorry, group all the addresses by domain. Then we sort each of them and sort of apply the sorting idiom on each of the domain groups, and then just sort of pull this nested structure back into a character matrix again. Then all of the addresses are in a new order, so I have to this time I'm again splitting these matrices by delimiter and then applying quad C to normalize them. So now I've got normalized domains but in the right order, and then I can get my sorted email addresses just by indexing using the grade of my normalized. So grade tells you where the indices of an array if it were sorted, of the elements in an array if it were sorted. So I can use the grade of one array to sort a different array. So there's my sorted email addresses. Yep. And then basically if alpha is 1, which by default is not, then first thing we do is create this Boolean matrix, which is basically it's 1 where the at is, and then the or scan basically covers up all of the domains, and then quad C at basically means apply quad C at all of the places where it's a 1. Just injecting this one cut here to talk about the unique mask part, right? So I got as far as lowercasing or case folding just the domains, but I did not show the last bit of code, which then gives me just the unique ones. To be fair, there's not much to it, right? It's SEA compressed by the unique mask. And so, yeah, since I've case folded all of the domains, then these two suddenly are the same. So unique mask blanks one of them out, and that's how I filter. Right. Anyway, so that was sort of my first attempt, but of course through doing that I realized I'm doing the same processing twice, and the repeated sorts like that. Okay, you can't avoid doing the multiple sorts, at least for my current approach like this. But what I did realize is that I didn't have to deal with the values all the time. It'd probably simplify the whole process if I just deal with the indices instead of the indices of each email address in my list of email addresses, rather than the content, the text, the emails themselves. So once again, okay, I want my matrix, and I'm doing the same thing about normalizing. But now, when I do dgroup, instead of grouping the values, as you saw before, this time I'm just taking the indices from the original matrix. Right, so this is grouped by domain, so 1 and 3 is the first email address and the third email address. You can see they're part of the same domain. And it's also been through the normalizer, right? So 2 and 4 says that these are both from CPAN, and then 5 is in a new group. Then, okay, sorting within each is slightly fudgier, I guess, now, because it's not quite the sorting idiom. So maybe this version actually would be worse in terms of speed, just because this part I have to index back into. I'm indexing back into my grouped addresses. From my groups, I'm indexing back into my address matrix, so that then I can sort within each group. So yeah, that's probably not as efficient. Then we get our sorted email addresses again. Once again, it's very similar, but now we have, so our normalized addresses, if we grade the unique ones, then that gives us the order that would sort these, right? It would sort our domains. So if alpha was first, cpan second, example third, then it's sorted. So we can use those indices we can use those indices to sort into our groups, hence putting our groups in order. Then enlist sort of takes away all of that structure, gives me just the numbers, and then it's just a matter of indexing into my original array to get the sorted version. And then the processing about unique only as before. So, yep, that's kind of my approach. Not that happy with it overall, and as I said, I didn't manage to get onto the end queens part, but check out Defun's website if you want.